So, hello and welcome to Helmut's talk about DPKG root.
Thank you. Given the readability of slides, I've put up a link below so you can read the slides independently. Yeah, I'm Helmut and I spare you the introduction of myself. I'm tackling the question of DPKG root question by question. I'm not going to read them now. We may see that a question doesn't go into detail as much as you would like to see. That may be answered in subsequent questions or after the talk. So without further ado, what is DPKG root? And first and foremost, it's an environment variable, and it is set by DPKG whenever it calls into a maintainer script at installation time. What you're supposed to do with it is prepend it to paths that are being operated on. What that means precisely is something that comes a little later. This is the executive summary. The variable is always set since Debian stretch, so you basically don't care about backwards compatibility or like that. In the usual case, and that basically means most of the time it really is empty, literally. We're about to figure out when not. It is actually a niche feature that is basically only used in architecture bootstrap. So the idea is that most packages don't have to care about it, which is something we're about to see. So the first thing I'm going to introduce is how to actually use it. We're talking about package installation here. So I've tried to depict how that actually works. We are installing a package with dpkg-i, and it'll unpack the files somewhere, and then it'll run a maintainer script. On that maintainer script, maybe running some tool. That's easy enough, I suppose, so let's make it a little bit more complex. I have now added the system where this is running around it. So that this is supposed to represent your installation on your machine somehow. And I've also added at the bottom the DPKG root variable over here. And yes, it's still empty. So this is just how it works normally. So let's level up a little bit. What you also can do is add a change root. So you not install the package in your system, but into a change root within your system. That can also be a container. And when you do that, you can kind of have a system inside your system. So I made this change root fit inside the system. And as it happens, DPKG root remains empty. But we can not only change root the full installation, we can also ask DPKG to do it on our behalf. And that has basically worked all the time. There's nothing new here. We just call into DPKG, ask it to do it inside some change root, and then it does. The difference here is that now we are using the DPKG executable that's not part of the change root, but the one outside. And when it runs the maintainer script, it actually does the change root. So the postinst interpreter and the actual postinst and the tool actually runs in a change root environment. And that's why DPKG root is still empty. Great. So this is where it becomes more interesting. We have added a new flag, this force-script-chrootless, and when we add that, we discard the change root. So this time we are actually running the postinst with the interpreter outside the change root, and the tool is also running outside, but it's supposed to operate on the change root. And that's why DPKG root is no longer empty, because that's how it tells the maintainer script what to operate on. So now we've seen how to use it. The question is, why do we need it? And the primary purpose is doing foreign installation of packages in a change root. And with a foreign installation means some architecture we cannot run on our processor. And a usual way to do that is QEMU, but QEMU is commonly not working well during early architecture bootstrap. So we somehow want to do without QEMU. And this is where DPKG comes in. It allows us to install a minimal system for foreign processor architecture. What it can also do is vastly speed up foreign installation, but that kinda is out of scope because the maintenance effort required for making DPKG root work across packages is not entirely trivial, so it's not what we like to do here. Which packages should support it? Yeah, it's for architecture bootstrap, so it's kind of something with a build essential, yeah? And that actually means it affects around 50 maintainer scripts and 150 binary packages. Those who are affected probably already received a patch. It only affects installation because it's like we have a set of packages and want to create this change root to package it up for the system that's doing builds, and we don't remove packages, we don't upgrade, just installation. And many of the package maintainers involved have already applied their patches, thank you, except for 3 left. If packages beyond that set want to support this feature, that's basically fine, I don't mind. So how do you do it in your maintainer script? So I said that a maintainer script operates on files. So whenever you use generic tools that work on files, you have to prepend this dpackage variable, a root variable, to the actual path. Looks simple enough. A number of things remain unchanged because they actually know about this variable. So whenever you use triggers or main script helper or uptilt alternatives and a few other things, you don't add it because these tools actually inspect the variable and act on it. And that makes modifying maintainer scripts a little easier. We actually test that this works. There is a demo repository that regularly performs the bootstrap with it and verifies that what we bootstrap with change rootless is identical to what we do without. This repository contains the remaining patches that are not yet applied, so we have a reasonably good understanding of this is going to work. And if it is going to break because someone changes the maintainer script, we'll probably notice. The other question that might arise is, why is this a force flag? And the reason here is that we need some way of telling that a package supports this mode of operation, but we have no such declaration. We could say rules requires root and add a new header to it, but we haven't done so yet because it's not entirely clear what this is supposed to mean, because you have some requirement on the outer system of having those tools available that are needed to operate on the change root. And the basic idea we use here for now is we install everything we want inside in an extra change root that we place outside, but for the native architecture. It makes things a lot simpler by adding a lot of packages in between. And if we want to move away from this, I've had a rough idea on how to maybe make that possible. We could eventually consider splitting our notion of dependencies into a concept of runtime dependencies, which is something you need for using the package and maintainer dependencies, which is something you need for installing, removing, or upgrading packages. The RPM package manager actually has limited support for this. It may be a totally bright idea, it may be a totally bad idea. I'm not actually sure, so if you see something that is improved by this, or you see something broken by this idea, I'd be happy to know. One thing that it may improve besides depackage root is actual stable upgrades, because we may be able to break dependency loops. It may become possible to configure a package with just its maintainer dependencies while not having satisfied its runtime dependencies yet. So it may result in fewer dependencies being relevant during an upgrade. So that's about it for the feature and the questions I've prepared. You may ask questions. I would like to place some thanks to contributors to this little project. We have a wiki page that explains some more ideas on how to tackle this problem. And if you have any questions around this beyond the talk, I've added a mailing list and an IRC channel for help. So now I'm ready for your questions. Thank you.
So the obvious question, which packages still have patches to go?
I'm not, I actually don't know it offhand. It's 3 left, and the one that is important probably is PAM. The other ones are not as required. It's more a reproducibility thing, I think.
Because of the difference in architecture, I assume that if a maintainer script calls the software that is being installed, that's going to fail.
No, you can't call binaries from the change root. Yeah, that's the whole purpose of the exercise. If you go like change root, depackage root, do something, well, then it's against the purpose. It really doesn't work like that.
Like if I'm installing foo database and I run foo database in it, there's a conflict of architecture.
Yeah, well, you can run your database utility. You just need to make sure that it comes from the outer system,
right, okay.
And not from the change root.
Right, so you run, okay, but the package is unpacked. So it needs to be installed outside also.
Yeah, that was the thing about the unclear requirements on what does it mean to support this mode of operation. And the current idea is that when we create an installation containing a set of packages in a change root, we expect that all of them are already installed outside.
Right.
In the same version for the native architecture.
So with force, it means I know what I'm doing, therefore I install foo-db outside and then
yes.
run the postings, which will call the outside thing with the inside path. Yeah, makes a lot of sense, yeah.
Yeah, it's not your maintainer script actually doing the installation, but the one using depackage root.
We have 5 minutes more for questions.
So you mentioned you are testing this already for the existing packages. How is this achieved automatically? So how can you ensure that there's no regression coming in on the long run? Yeah, maybe it's also related to the question, how could this be scaled? Because if we have QA running on the packages, I guess you could also spot if furthers could be enabled or if furthers got problems, so you can scale the amount of packages you could support.
I'm not sure I understand the question. So what we do is we have this CI job, which runs, I think, once a week. It builds the remaining packages with patches and then performs an mmdep strap with this option enabled in the double sandwich change root mode and in the normal mode. And just compares the output, and if there is any difference, we get alerted.
So this is what you have in your environment, so to say.
Yes.
If you want to enable a package maintainer to do the same thing upfront, is there anything what the package maintainer could pick up?
No, I think we don't have anything for individual packages yet. But that's maybe kind of out of scope. We have a target set that does need support this, and I don't think it makes sense to go beyond, because adding support actually is little involved, and keeping it maintained is not entirely trivial. On the bright side, the risk of breakage is fairly low, because you're basically adding an empty variable in a bunch of places. So the risk of affecting native package installation is basically non-existent.
Okay. Are there other questions? Are there questions from IRC? Okay, there are no further questions. Oh, there's a question.
I understand, or I think I understand the part of what you're trying to do, but I missed why exactly you want to do this. I mean, where exactly is it useful to do that one stream instead of the other options that you showed? Or full of this option?
So it is a step in performing architecture bootstrap. You start out with building a cross-compiler, cross-building all your essential packages, and then you have some package set to start building natively. And you need to somehow get from a set of binary packages to a system that can actually do package building. And this is the step we are solving here. Going from cross to native.
Okay. I'm looking around if there are other remarks.
Just a minor remark, and I'm sure you've already thought of this, of course. Going through and extending all of the paths potentially in a post-inst might be quite error-prone. It's the kind of thing, you know, cut and paste errors are going to bite you. Wouldn't it be nice if there was a better way, but I can't think of one.
So the other approach we've tried is deleting maintainer scripts. Yeah, a big chunk of the patches we've used here is like, this is obsolete, delete, and getting rid of them. And going anyway, declarative maintainer scripts is also helping a lot. Yeah.
I mean, that's the obvious way to go.
Declarative metadata in packages is something that's somewhat happening in the package. Declarative creation of users, things like that.
Thank you.
We would have time for a last question. Doesn't look like so. Helmut, well, thanks for your talk.
Thanks for the attention.